Hello, everybody, and welcome to today's vOLTHA TST call. Thanks for joining. As usual, the call is public and recorded, so please be mindful of whatever you share and comment during the session. First up is just a reminder to everybody that September the 10th is the code freeze date that we have for vOLTHA 2.5. So I would like everybody to assess what tasks they have, and keep in mind that there's basically 8 working days before the code freeze. So just bear in mind that for your tasks. And if anything needs review or needs testing, feel free to ping the vOLTHA channel to make sure that things that are in flight actually get merged before the code freeze. Any other thoughts on the code freeze? No? Okay. Then if not, I'll hand over the torch to Ken to give an overview of the transaction error handling on the core, from the core to the adapter and vice versa. Ken, take it away.
Okay, thanks. Let me share my screen first.
Please do.
Just give me 1 sec here. Just want to make sure I'm sharing the right screen. Can you see my screen?
Yes, perfectly fine.
Okay. So this is the transaction error handling in the vOLTHA core. So most of it's really the error handling between the core and the adapters, because today whenever we get a request from the northbound, for example from UF agent or the vOLTCTL, any request that comes into the core, if the core has a failure within it, for example, it cannot proceed with a request, it cannot write anything to the KV store, there will be an error that will be propagated back. So that's kind of taken care of today. Where things get a little bit complicated, it's when we get a request in, the core can process it successfully, means partial processing inside the core. For example, when we get an enabled device, the core will change the state of the device, will update the KV store with it, and then will send that request to the adapters. So what happened when an adapter come back and it's fail? Either we get a timeout or we get a failure. And I'm giving an example of an enabled device. There's a bunch of commands from the core to the adapters that has potential of failures, either because the system is over busy, means there's a timeout, or there's an actual failure. Today, how we respond to that? Today, the most common thing we do is we log that failure in the core, and in some cases we take some actions. In most cases we don't do anything. The only place that we really take action is when we are trying to add flows and the adapters has a failure or a timeout. At that time we remove those flows that we try to add in the core. And also we send a request to each adapters to remove whatever request we have, send them to add those flows. We say, okay, remove those flows. Those are really the only case we take an action. Most of the other cases is we just logged it and that's it. The problem with just logging it means if there's a failure, it's kind of a silent failure. No, nobody will really see it. In some cases, they will do. For example, if you enable a device and it's failed, chances are that that device, the operational state of that device is not active. So by just querying the device, we kind of have an idea that something has failed. But the purpose of this document is to see like what can we do better in terms of reporting that failures. So, and here I have a list of some common requests that we send back. This is not all the requests. This is just some common requests, so we can discuss about those ones and figure out what is the appropriate action that we should take. So let's go with the first one. Here I have list and get. Those are like really command that goes into the core. And like I said before, if there's any failure, the only failure really we can get is a failure from the KV store. So an error will return to the core. So in those cases, there's no really action, no any action required. So if we look at the second one for enable device, and in this case, we can get a timeout or a failure. Currently, chances are the operational state will not be active in the core. So if anybody query the device, it will be maybe activating or maybe a different state, but it may not be active. The connection state also may be different. So what should we do when we have this error? Should we publish an event to Kafka? Is there anything that we need to revert? Should we revert the enable request? For example, if the device was in a pre-prov state before, should we send it back to that pre-prov state? Or should we have a retry mechanism? What does anybody think about it? Any feedback on that?
So if you enable, say, let's assume you're using the vOLTHA and you enable the device, there's no way the user of this command to know whether the device has successfully enabled or not, unless he triggers a vOLTHA device list or something, right?
That's correct. Yes.
So the user of this command would anyway know if the object, so it's administratively enabled, but it may not be in the right operation state. So the only way to confirm this is to again list the devices, and the operation state should, or connection state should give the user a feedback on what has actually happened. So are you getting the point? So basically, I don't think core should try to revert anything. A subsequent invocation of the device list command should give the object state, and the user can go ahead and do the cleanup necessary if the object is not in the right state.
Any other opinion on that one? Keep in mind that if there's a timeout, if the system is extremely busy, and if we set a timeout to a low value, there's a chance that operation actually succeed on the adapter side, but the core receive a timeout because the timeout was set too low. So go ahead. Was it Sora that had a comment?
Yeah, I guess I was suggesting that somewhat similar to Girish, that that I wasn't keen on a retry or a revert sent to the adapters. If you're trying to administratively activate the device, almost always the operator is checking if the device got activated using a device list. The device list can perhaps have a state update on it to show that something has errored out or timed out or some reason. Right now, the device list I guess the operational state will still say activating or something like that, but maybe it can say error timed out or error some other reason. But I don't necessarily think that you should revert or retry.
Okay.
Because of the nature of the system, where its distributed communication could be disrupted, you know, I like the idea of, look, the command's been issued. It's kind of the system kind of acknowledges that it has the command or that it's passed on the command. But yeah, everything else is kind of an asynchronous query, what the actual state is. You talked about a timeout between the core and the adapter. I almost think that even in that situation, the core passes the command to the adapter essentially acknowledges to the core that it has received the command, and at that point, that's all the timeout should be waiting for. Everything else from that point should be either an asynchronous event to show a state change in, you know, an error or success or whatever, or get that information by query. So I would hope pretty much eliminate the concern about a short or a long timeout.
There's two level of the way a request is processed in the core send that request onto Kafka and then responds back to the call. Like, for example, vOLTHA CTL saying that we have successfully sent that request over Kafka. And then after that, we start a timer and we wait asynchronously for the response. So what you're suggesting is, instead of waiting for the final response, we just receive an ACK from the adapter, and after that, wait for subsequent responses as well?
Well, again, I guess the question is for like enable command. That kind of works, right? You basically, this vOLTHA returning a success basically says, yes, I've issued the command's gotten to where it needs to be. A device list, by definition, has to wait for a response or a timeout. But if the device list is only coming from the core, there's no issue between a timeout between that and the adapter. So what request from the adapter requires a wait from the core?
Because all those commands are treated almost the same, in a sense of we send a request to an adapter and then we wait for a success or a failure from the adapter. So in the case of enable device, it will just be, yeah, I enable it. In some other cases, it will be like, okay, give me some data where we actually need to wait for some data. So the wait here, it's really like a success or a failure in most cases.
But it doesn't wait for example, in the enabled device use case, it doesn't wait for the device to actually be enabled.
I know.
Okay.
Well, in the case of enabled device, it's a little bit tricky because it sends a request to the adapter and then it waits for a response. The adapter, it's up to the adapter to tell us whether the request was successful or not successful. But during that time, the adapter is updating the device states, the operational state. It's the device reason. So there is update that is happening to that device in the core from requests from the adapter. And at the same time, the core is waiting for a final response from the adapters to say that enable has succeeded or not. So there are two things happening at the same time.
And different adapters could implement that differently.
Exactly. Should we care about the timeout? Like, should it be something like, well, let's wait forever?
I don't think it should be wait forever.
Or a very, very long timeout.
Well, you know, if for some reason the device is, I think in the OpenVOLT, if the device is not reachable, yeah, I think the enable would immediately fail. I don't think it retries. I have to check. So basically, if the device is not reachable, you know, the adapter, we don't want the adapter to go on retrying forever, and the core is also, you know, waiting forever on the response.
Mm-hmm. I don't know if the adapter retries forever, but it retries for a while.
Okay, I don't recall the behavior. Yeah, that is something that we need to check. We don't want the core to wait forever. Ever. A timeout is, I think, the best way forward.
You know, my mind keeps going back to how kind of Kubernetes does things, right? When I create a pod and I get a successful message back that the pod's created, all that really means is it's been created in the essentially desired state database, right? And then there's systems in the background that maybe retry. I can watch events to see if things are successful. But again, kubectl kind of returns immediately once the data's in the system. And I keep thinking, is that kind of a behavior we want to model?
We're kind of modeling it in a bit, right? Because we are changing that state in the KV store, and we're sending that request to Kafka. Mm-hmm. And then we're sending back a response to the user.
Right, but the difference is when I create a pod, I don't wait for the container to actually be created unless I, you know, actually specify wait, I suspect. I think there actually is a wait option. But by default, it basically is a fire and forget almost, and then it's up to the operator to watch the state. And if we're saying that there's a retry, or if we're saying that the core talks to the adapter and tries to enable the device, and that could potentially take a while, there's a difference there, right?
Yeah, but it's an asynchronous wait here. Like if you issue the command from vOLTHA, you get a response back that it has been created in the core and the request was sent to Kafka.
Okay.
And then asynchronously, the core will wait for a response.
Okay, but that won't, my original call to enable won't be blocked.
No, it won't.
Okay.
No, it won't.
All right.
That's why you'll need to do a device list.
Yep.
To make sure that it's enabled or not.
And I think that's appropriate.
Okay, so are we tending towards no retry and don't revert the change? And do we want to publish anything to Kafka for those kind of state errors? If we do, is there any system listening to it to take action?
I don't think it hurts to publish to Kafka. I think it can be useful.
I agree. I think publishing state change events and errors to Kafka is appropriate.
Okay. So can I say that we will do the same behavior for disabled device and for disabled device, we'll do the same thing.
Agreed.
I would agree. Yeah, that basically all commands kind of do that.
Okay. So for delete device, that's a special case where the core will just go and delete the device, and it's a don't care scenario from a core perspective, in a sense that we're sending the request to the adapters to delete, and we're removing everything. Is that okay?
Sounds good to me.
But I would think the adapters are still sending events when they delete it, when they actually do the delete, as well as the adapter send an event if they try to do a delete and it doesn't work, right? So I think events are still potentially coming up.
Yeah, events are potentially coming up, but if that data is gone in the core, we'll just say, well, data is gone.
This is, I guess the question is, or does it, when I delete it, does it go to a kind of pending delete status? You know, when I say delete, I'm essentially marking it for delete. It should be recorded as pending delete. And then when it's confirmed delete from the adapters, that's when it's deleted?
No, it's like there's a set of transitions that happen. For example, if we're trying to delete a parent device, then we'll go and disable the child device and delete the child device. And then it will start to delete itself. If we delete a child device, we'll just go and delete and disable and delete the child device. So there's no wait for an event from the adapter to say, okay, I've deleted it, you can go ahead and delete it. It's more
right.
Go ahead.
My question then becomes, if I delete the device and the adapter fails to delete the device for some reason, how do I as an operator understand that, other than listening to potentially the event stream? And how as an operator do I correct that?
From today, there is one today. What assume we are going to publish something on Kafka. Other than that, the only thing that you will see when you do a vOLTHA query the device, it will disappear in the core. But that doesn't mean it doesn't exist on the adapters. That's a scenario that is kind of very specific to delete today.
Right. See, it seems to me that a delete, I guess there's a state for commands. The system's accepted the commands. The command is pending completion. And then when an event comes, and at that point it's returned to the caller that say I've accepted the command. Then when the command is actually complete.
Really important. Sorry, David, we lost you. At least I lost you for 10 seconds. Go ahead and
I could actually hear you, David. Maybe
maybe it's my connection. Okay.
Yeah.
So just to repeat, it was there's a state in the system where the user issues a command, or an API command comes over. The system or the core acknowledges that command, has it in its command queue or in its data state change, if you will. And that change is essentially pending. In other words, we understand that you want to make that change, but it actually hasn't been implemented yet. Then the commands go to the adapters. And at that point, the adapter makes or doesn't make the change and publish in his event. And at that point, the core can essentially say, yes, this actually happened. That way, if a delete happens, the core sees it as, hey, I've marked this for deletion or pending delete, sends a command to the adapter. If the adapter fails to delete it, well, there's couple situations. If the message fails to get to the adapter, the core can reflect, I was not able to communicate to the adapter. And maybe there's a background retry in that. We can talk about that later. Or the command gets to the adapter and the adapter fails to actually delete it, in which case the core can then say, look, I had an error at that part, and gives the operator, again, a capability to do something about it. Or it succeeds, and at that point, it is removed from the system. And you could actually argue there's a purge, a delete and a purge, but that's a different issue too. There's this pattern, I think, that we need to take into account, that the core can't change data such that an operator has no way to correct the system anymore except to restart. And at least in this delete case, there's a possibility that the core deletes the data. It's still an adapter, and the only recourse is a restart or an etcd tweak somewhere. And I don't think that's an acceptable state for the system to be in.
So yes, you're right. I mean, the delete is a really special case, and we depend on it to purge the system. So you're saying that the system, so the core should not purge it if the core succeeds, but the child adapters don't succeed?
We have to give the operator some mechanism to correct the system or understand the system state and then correct it. And if there can always be the possibility of giving the operator, hey, look, I know that there's some problems, and do a force kind of thing, which basically would continue to wipe out the data.
So if a delete fails, you're saying there should be an additional command, purge.
Well, no, purge is different. Purge is different. What I'm saying is, if a delete command fails at the adapter, we can't leave the system in that state, in a state where the core no longer knows about the device, but the adapter does, because then the operator has no way to understand the system state nor correct it.
Okay, so what is the correction then? What is the correction?
What I'm suggesting, and it may be completely wrong too, is when I delete a device, the core essentially has it marked for deletion pending, whatever you want to call it, and it stays in that state until it actually can verify that it's been deleted from the adapter. And that core, the state of it's then updated, the core can get events from the adapter to say, yes, it was deleted, no, it wasn't deleted, here's the error, or I haven't been able to communicate to the adapter. And the original case I thought we added to purge the data directly or remove the data completely from the core was what happens if the adapter goes away or the OLT goes away, and I just really want to erase the data from the core. I know the system state. It's a very dangerous operation, but I know the system state, and I just want to remove the data. And I still think we have to support that. Typically, that can be supported with a force option, which basically you go to the core, delete -force, and at which point you're saying, look, skip the whole pending thing, just wipe your data, send the message, whatever, but just wipe the data. But that is a kind of an operational decision made based on the known state of the system.
I like the idea for delete -force.
Yeah. To give some background on that, I think when we were, like a while back, we were doing this delete, and I believe there was a wait from the adapters for the adapters response. And then we changed that to make it a false delete, because there were some scenarios, I can't remember which scenario, where the adapters were not responding. And and then after that we said, okay, make it a false delete. But in the core, to make it to have this option of purge, that's quite simple, because today when we do a delete, we change the state of that device to deleted, and then we run a set of callbacks, and then the last callback is the one that actually delete the device. So we could easily just change the state to deleted and wait for the adapter response, and then proceed with the rest of the callback.
Right.
So in the core, it's not a big change there for that.
And then you want to update the state of the record somehow as events come back from the adapter, so that when I do a device list, if the adapter failed to delete it, I see the error why it failed to delete it. Or if it timed out trying to communicate to the adapter, I see that. And then the question becomes, if I delete a device and it fails to delete, and I'm aware of that now as an operator, is there an automatic retry in the background, or does it stay in that state till the operator comes back again and says, delete, retry, or whatever it is? Right?
Mm-hmm.
That makes sense to me, but what will be the, say, behavior of the core in deleted or delayed state? And which one is the corrected state? I mean, is it admin state that we put into pending delete or delete, or operation state?
No, it's an admin state that goes into deleted state.
Yeah.
Okay, then we have to define the behavior of core in delete states.
So in deleted state, pretty much the only action that can be done on that kind of state today would be another delete coming in, and that will try to delete that device. Any other action will not be processed on that at that state.
Yeah.
Okay, then if this is an OLT to be deleted, any indication from an ONU that is connected to this OLT will be discarded, as well as the indications from the OLT itself.
It's a good question.
There would be certain, for example, if they want to update certain state from the OLT or from the ONU, certain fields, we can allow certain fields to be updated.
Yeah, is the operational state of a deleted device continue to be updated?
I think that I need to double check that to make sure that we have the right check over there.
Probably if you fail to change or delete this device from the adapter, then you probably will get indications from device.
I think the indication should at least be logged, right? Now, if we also want to update the operational state, that's an option too, right? Even though it's marked as deleted, there is an operational state.
When a delete goes to an adapter, what kind of operational state would the adapter send back on a delete action?
I think the issue was what happens if the delete failed at the adapter. Does it still then, then it sends back an event that hey, I couldn't delete it. Is it still tracking the operational state?
Actually, the delete operation is never a failure of the adapter. It's always a success, at least in the OpenVOLT adapter case.
Yeah, good adapter, delete always will work.
Oh, it does update the state for a delete device. So I'm checking here. It tries to update the state, operation state as unknown and connection status as unreachable. And if the state update to the core does not succeed, it returns an error. So that's the only case. Okay, and there is another case. So after the device is deleted, it tries to reboot the OLT. And if it's unable to connect to the OLT and reboot, it returns the error. So there are two cases a delete device could fail. One is it's not able to reboot the device. And in another case, it's not able to update the states back to the core.
So what it means is there will be some state changes in the core following the delete.
Yeah.
Okay. Okay, then we need to allow that to happen. There was, I think Saurav alluded to that, and also David alluded to that. It's like to have a field in the device that will update with the error status. Currently, there is a reason field that typically is being used by the adapters to update certain reason. For example, like flows has been downloaded, for example. Should we reuse the same field, or should we add another field for communication between the adapters and the core for a specific device?
At the risk of making life more complicated, but also following what is done in nature, i.e. Kubernetes. It has a list of events associated with the resource, right? When I look at a pod, I can look at the events of that pod if I do a describe on it. The problem with a single reason field is you lose history the minute it's set again. And so having the reason be kind of the message from the last event may make sense. But if I describe a device, it would be nice to see all the reasons because they're not necessarily mutually exclusive.
Correct.
And so unless we provide a mechanism that we allow that, like events, like an event list associated with the resource, we lose that capability, i.e. I could do a delete and the adapter could throw back a reason why it was deleted, but then it could get another ONU notification that slot, overwrites the reason, and now I've lost my error.
I like that idea with that. Currently, your reason is just a string. So do we need a list where we'll have some, for example, a timestamp with a reason to it?
It's kind of what I'm suggesting.
And do we want to have a limit to that, because that list can grow quite a bit?
It can. I don't know. I think we want some sort of limit. It's probably a configurable limit in the long term, right? How many, whether that's a limit based on number of events or a limit based on time, I don't know, but some limit would make sense.
Okay, cool. Is everybody okay with that approach? Any comment?
Everybody's just wishing I'd shut up. That's what they want. They just want me to shut up.
No comments means we're in agreement.
The output of the Vault CLI will be a bit, ugly.
Again, I'd mimic Kubernetes here, right? If I do a describe, I get to see the list of events.
Yes,
if I describe a pod.
Yeah, that's what I'm going to say. We may need a describe in case.
Yeah. We have it in spec right now, which is essentially describe, I believe. We can expand that one. I have to admit, in the back of my mind, I've actually thought of some major changes to vOLTHA, but they're fairly disruptive. But it'd make it more like kubectl.
Okay, I like this idea of having that a list of reasons. Just make it much easier to view the history of that device.
Yes.
Okay, so the next one is reconcile device. Unless we have any other question on delete device. For delete device, I said we're going to wait for the response, and also we'll have a false option.
Does that mean the vOLTHA command would hang until the delete device is complete, or you would immediately get back a response and then you have to check again?
You'll have to check again. It won't wait.
Okay, got it.
For reconcile device, today also we just do logging, and so we'll publish something on Kafka. Do we need a retry in that case? A reconcile device typically is when an adapter is restarted.
Does this follow a similar pattern? Again, does the device go to I'm reconciling state? And,
it doesn't have that state today.
I know. I'm making more work. I understand that. But does it go to the I'm reconciling state? So is there a seal? So it goes, I have a state reconciling, so everybody knows what the device is doing. And then events are going back and forth as it's reconciling. But as an operator, again, I'm understanding what's happening. Does that make sense, I guess?
It does make sense. Do you want to have it as a separate state, or if we have the list of reasons, then we can add that as a reason?
We can add it as a reason. I guess the question is it a state? It's absolutely a reason, but it's also a state, because when a device is reconciling, I'm assuming there are certain operations that are not allowed. Is that true?
Today we don't have that state, so it's
okay.
We can limit. We can set it whatever we want it to be.
So I guess the question is, when a device is reconciling, are there certain things we want to prohibit from happening? And if so, then I think it's a state. If no, then I think it's just a reason or an event.
I would think like will prevent any flows being sent, because it's reconciling means the other end is not there.
So to me, that's like a state then, right? Because I'm going to make decisions on it. Likely the system can only make decisions based on a state, not on an event, because an event is something that happened at a point in time. If reconcile is just an event, I see it, 12 o'clock, reconcile, or begin reconcile. Maybe I have no way to know if I'm still reconciling.
Yeah, correct. Yeah, that would be a state change, because pretty much reconciliation today, it means it's a request that's sent to the adapter and says reconcile this device. So we don't have a feedback coming from the adapter says I finished reconciling. So it would be nice to have that. Any other comments on around reconciliation?
I wasn't sure what the conclusion was.
The suggestion is to create a new state for reconciliation, so that when an adapter goes away and comes back and want to reconcile a device, then we'll set that device state to reconcile or reconciliating, and then send that request to the adapter. And then after the adapter says, okay, I finished reconciling that device, then we send it back to its previous state.
Okay, so no change on the adapter side, right? It's just a state.
It's a state change.
Display on the core, right?
Yeah, it's a state. We need to add a state, a reconciliation state. And I just need to make sure that that today we don't expect anything from the adapter. Like we need to make sure that we can transition that state, a reconciliation state, to a reconciliation complete or enabled state, whatever state it was before.
Yeah, it's a reconcile sort of similar to a reboot operation. And this is like when you do a reboot, you request the device to, of course, do a reboot. And after it's completed, it should re-enter the enabled or disabled state. Likewise, while you're rebooting, if you do a delete request, you should be able to delete and leave. So is a reconcile sort of similar to that?
I think the reconcile was about, say, the adapter restarted for some reason, right?
Yeah. But what I'm saying is that if you have a reconcile state, after you finish reconciling, you should go back to either enabled or disabled, right?
Right.
Yeah. So how so it's the enable and disable commands are like events that cause a state transition. A reboot or a reconcile is sort of a temporary phase. So
yeah, but I don't know if the adapters have such a enabled or disabled state associated with them, right? The I mean, it's for the devices that we do enable, disable, not for the adapter.
Yeah, I mean for the devices. Sorry. Yeah.
But so the only reason we're talking about a state for the reconcile case, it's more if there's any action that we want to prevent on that device, if it is in reconciliation state. Like, for example, do we want to add flows when a device in reconciliation state?
But where will the state be visible?
It will be visible only in the core.
No operation should be allowed during reconciliation state.
So in that case, it needs to be a state. It can't just be just an event.
Yeah, it cannot be any reason code or something. It has to be a state.
But I'm not aware of any place where I check adapter state. I don't.
No, we don't
Is
have
there?
no, we don't have an adapter state per se. We're talking about the device state here.
State.
Okay. Okay.
Saurav, there is no reconcile adapter. There is only reconcile device.
Yeah.
Okay.
So are we in agreement to create a reconcile state?
Yeah, and this is what, an operation admin. What state is this?
That would be an admin state.
Okay.
Unless we want to make it an operation state.
I have no strong opinion on that.
Well, the admin state has already been declared, right? We want this thing enabled, right?
Mm-hmm. Yeah.
It's in operation that you find that you're having to do this reconcile.
Yeah. Yeah, makes sense. So it's it makes sense to be an operational state then.
Yeah.
Yeah, that sounds easier to manage.
Yeah. Okay, perfect. So after a device has been reconciled, then the adapter will change its operational state. Correct?
Yes.
Okay. Okay. So any other comments on the reconciliation of device?
Well, when a device is in a reconciling operational state, are any commands going to be disallowed? Like, you obviously don't want to do a reboot while reconciling.
Yeah, correct.
But you may want to delete or disable.
Do we want disable to be allowed?
While the device is reconciling?
Yeah. I can understand delete.
In normal operation, I wouldn't expect anything except for maybe delete to come in, because you don't really just enable, disable devices willy-nilly like that. So.
Mm-hmm.
Reconcile basically means I'm really confused. And so I think you definitely want to limit what you can do.
Yeah, I mean, the adapter is still building all the states during reconciliation. It may not be in the right state to handle any requests for that device. So
yeah.
Yeah. So will it make sense to have a delete at that time, or even delete? We just prevent it. Like, what would the device do if it's in the middle of a reconciliation and receive a delete?
I do a cleanup. I do a full shutdown. So a delete's a very easy thing for me to handle, because it's in the background. What I do for reconciling is an audit process where I go through the device, then through the ONU and PON capabilities into the flows. And when I get a delete, I basically say, okay, stop all auditing, stop all OLT communications, start cleanup, and send a reset to the device, because I'm gone. And that's a very easy, fast cleanup procedure for delete during a reconcile.
Okay, is it the same for all adapters, like OpenVoLTHA, ONU?
I just give me a minute. I'm just checking a few things.
Yeah.
In general, delete is a good thing to allow. Just, I mean,
yeah. Of course, we
someone
have
loses.
delete force now, so.
Yeah,
Okay.
that's right.
I said kill it, and I mean it.
Yeah, but the difference is, like in this case, because we are changing the delete to wait for a response from the adapter. So in this case, we're sending a command saying reconcile, followed by delete, and we expect the adapter to respond, right, to that delete before we remove everything.
Well, the thing with OpenVoLTHA adapter is if the device entry is not still there in the cache and the delete comes in, so basically we are still handling the reconcile, and the entry is not there in the cache, it would say I have deleted the device, but we are still in the process of creating these entries in the local cache. So there could be a race condition, especially in OpenVoLTHA. Let's assume both of these operations come out simultaneously. So does that not happen in case of Tibet, Chip?
What do you mean, getting a delete upon a reconcile?
Yeah, I mean, let's assume you get both these requests simultaneously.
Yeah. Ours is a little bit different in that sense. We're still with a twisted architecture. We're able to have a deferred, and we can do a cancel command, and that cancellation has a ripple effect through my subsystems. So when I actually do a major state transition like delete, I'll do basically I do a cancel, which shuts down my audits. So it's okay. Let's change. So I can do a delete at any point and do a nice cleanup. So I noticed in the OpenVoLTHA adapter, it basically does a go command and spawns off a task to do an operation, but those aren't necessarily cancelable. You can't cancel those in progress. So that's a little bit different in the architectures.
Guys, I hate to break the news, but we are, in order to be aware of time, we only have 5 minutes. I'm okay staying over a little bit, but some people might not. So let's tackle as much as we can, and then we'll reschedule the rest of the topics next week.
Okay, so basically what I was trying to say is if delete and delete operation and reconcile device operation come almost simultaneously, the behavior could be unpredictable. At OpenVoLTHA adapter, it could be an architectural issue. I mean, at this point, I cannot say for sure. It could be undefined behavior. So I would say, while reconcile is happening, just don't allow any other operation. That would be very simple. Yeah, that's what I would say.
Well, we might want to be able to do the delete force capability, because what happens if you're you've been in reconcile and you're just not getting anywhere. So
yeah, the only difficulty in the case of the OpenVoLTHA adapter, even if we do a delete force, and the code will be gone, but there's a likelihood the reconcile will still keep going, and that device will remain in cache in the OpenVoLTHA. Is that correct, Yuresh?
Sorry, what was the last point you made? I lost it.
Even with the force will guarantee that the core is not going to wait for a response from the adapter. So the core will remove everything in the core, but there's still a chance with a force or without a force that in the OpenVoLTHA, during that reconcile process, if those two actions come very close together, you will still end up with a device in your cache. Is that correct?
I don't think so. It's the action of creating an entry in the local cache is very quick. So what I'm saying is you have not created an entry in the map yet, and the delete device has come. And there could be a problem because you're not finding any entry in the map, and then you just say, there's nothing here, and you return success. But if you trigger a force delete, and that comes, let's say a fraction of a second later, I mean, you already have the entry in the map. So that shouldn't be a problem. So it's very transient. I mean, it happens in fractions of seconds. So I don't think force delete should cause any issues because we already have an entry in the map.
But if you don't have the first, if you have just a reconcile followed by delete force, and that entry has not been created in the map yet, but you got that delete force, then you will say it's deleted. But then after that, you will end up with an entry in the map. Is that possible?
No, that's what I'm saying. That's not possible because creating an entry in the map it's very quick. I mean, it doesn't take a lot of time, and we shouldn't be landing in that problem.
Oh, okay. But that should also be the case without force, right?
Sorry, what was that?
That should also be the case whether delete is with force or without force.
Yes, so if you're reconciling, so delete force is always followed by the delete, right? You wouldn't, I mean, if you trigger delete force first, then there could be a problem, yes. If that's what you're asking, if reconcile and delete force are triggered almost simultaneously on the adapter, yes, we could end up with an issue, yes.
Yeah, so can't we use the state variable of the device to figure out what is happening?
No, we can.
When we're reconciling, the state should be reconciling, right? So if you get a delete when we're in reconciling state, the adapter can handle it, right? That however it wants to handle it.
Yes. So if the reconcile device API is triggered on the adapter and the device structure that is passed to the adapter has the state as reconciling, yes, we could handle it. We could handle this situation.
Okay, but that would be the case in that scenario.
Okay, then that should be pretty straightforward to handle. I mean, these race conditions could be handled using the state variable. Yes, that should be simple.
Okay. Okay, cool. So the next, oh, it's already 12. but the next one should be easy. Back it out, it's a find forget operation, so we just don't do anything with it.
Yeah, if we really want to do something, a return to the OF agent is good enough. It could be an interesting thing because then at least we plumb it through vOLTHA, and we can see if in the future we want to return it to the controller. But for now, no.
Okay, so I'll update this page with what we have discussed, and then we can keep going for on next week. And anybody feels free to add more comments to that document.
Yeah, that's what I wanted to suggest. If people can take a look at the document before next week, so we have maybe a further discussion on the document itself, and we can get just to the conclusions next week because there are some other topics that need to be addressed next week. I apologize. Let me take back the screen.
Yeah, I just stopped sharing.
Thanks, Ken. So I apologize to Girish and for the other folks that had some other topics in here. We'll get to them next week. The error handling is very, very important, and so I think it's a worthy topic to have discussed. So with that, are there any final comments on this? And if not, thanks everybody for joining. I'll make sure to publish the recording so anybody can get back to it whenever he wants. And I'll talk to you on Slack, on the email. Please do comment on Ken's document, and we'll see each other in the call next week. Thanks a lot, everybody. Take care. Bye-bye.
Thanks.
Bye.
Cheers.
Bye.